Ever tried to vertex paint nanite meshes in the level to add some variation but realized you can't? Well, now you can, sort of. In the 5.5 version, Unreal Engine has added a new tab in the Mesh Paint mode called Texture Color. Unlike Vertex Color, this one can be used on nanite mesh instances. In this video, first we're gonna go over the new Mesh Paint material nodes and how to use them to create a Mesh Paint material. Then we're gonna go over how to use the new Texture Color tab and everything you need to know to avoid problems and get the best results. So let's do it. If you are not familiar with any of the nodes I used in this video, check out the material nodes playlist on my channel. Also, you can download the project file of this video on my Patreon. I'll put the links in the description below. What is texture color mesh painting? In Unreal Engine 5.5, we can now mesh paint on nanite mesh instances. In the previous versions, as I've mentioned in some of my videos, we couldn't add per instance vertex painting for nanite meshes. Nanite didn't allow these common mesh painting workflows which allow local variation of appearance for instances of the same geometry. We could vertex paint them, but through the modeling mode, and that would affect the source static mesh in the content browser, therefore affecting all the instances of the mesh used in the level. That wasn't really useful. Now in the 5.5 version, Epic has implemented a new feature to the mesh paint mode named Texture Color. It paints to virtual textures stored on mesh components and gives us the ability to have per instance variation for nanite meshes too. The workflow is similar to vertex painting, but it scales with texture resolution instead of vertex count, which works more efficiently with nanite meshes. We'll get into all that later in the video. Prerequisites. In order to take advantage of this new feature, make sure that you're using the 5.5 version of the engine. The Texture Color tab in the Mesh Paint mode and the Mesh Paint material nodes are not available in the previous versions. On the top right, click on Settings and open the plugins. Here search for Mesh Paint and make sure Mesh Painting is turned on. Next, we should enable virtual textures for the project. So let's close this. Again, on the top right, click on Settings and open the project settings. Here search for virtual texture and enable it. And if you're like me and don't like your textures to turn into virtual textures when importing them, make sure to disable the second option. Here are my virtual texture settings, and after enabling these, you're gonna need to restart your project for the changes to take effect. So go ahead and do that. Mesh Paint material nodes. Before creating a material, we should go over the new Mesh Paint material nodes. Right-click in the material graph and search for Mesh Paint. 4 results will pop up. These 3 are the ones we're gonna use, the ones under Mesh Paint texture. So let's add them. And let's add a texture sample to better explain what each of these nodes does. So hold T on the keyboard and click to add it. The first one is Mesh Paint Texture Object. Texture objects provide the texture to sample from and can be connected to the text input of a texture sample node. And then the texture sample samples from it. Let's right click and search for Texture Object. Here it is. Let's add it. We can't connect it straight to the main material nodes, but we can connect it to the text input of a texture sample and then use it in our material. Let's delete this. So we should connect the Mesh Paint Texture Object node to the text input of the texture sample. This way, when we paint the virtual texture on the static mesh components, it can be sampled through the texture sample node and then used in our material. The second one is Mesh Paint Texture Coordinate Index. In front of the UV's input of the texture sample node, there's a number, which is by default set to 0. This is the UV coordinate index. It specifies which UV channel of the mesh this texture is gonna use to project the texture onto the mesh. When unwrapping meshes, we have the option to add several UV channels. For example, let's open the default cube. Up here we have a UV drop down, and if we click on it, we can see that we have two UV channels, UV channel 0 and UV channel 1. This is UV channel 0 and this is UV channel 1. As you can see, they can be different. Let's go back to the material. So this number defines which of these channels the texture uses. We can use Mesh Paint texture coordinate index to define which UV channel we want to use for mesh painting. I'll go over how to use it later in the video. For now, let's keep it here. The last one is Mesh Paint texture replace. If we keep the mouse cursor on top of it, a tooltip pops up. It switches between inputs according to whether there's a valid Mesh Paint texture available. There are times where a material is applied to a mesh that doesn't have a mesh painted texture, or the platform doesn't support virtual textures that are needed for mesh paint textures. In these cases, you want to have a fallback option for the material to correctly render. On the default input, we can plug in any other material logic to be used in place of the mesh paint texture path. For simplicity, we could use a texture sample node or constant vector 3 to set a color, but let's leave it for now. We'll get back to it while creating the material. So we should place this node here and connect the texture sample to the mesh paint texture input. Next, I'm gonna create a material using these nodes. Mesh Paint material. Right click in the content browser and create a new material. Let's name it M_Mesh Paint and open it. First of all, in the details, search for nanite and make sure used with nanite is enabled. Hold 3 and click 2 times to add 2 vector 3s. I'll set this one to a light gray. And this one to red. Hold L and click to add a lerp. And connect them like this. Mesh painting with texture color is the same as vertex painting. It's just that instead of the vertices of the mesh, we paint on a virtual texture. So the process of creating the material is the same. We should use the mesh paint texture as the alpha of the lerp, so that when we paint on the mesh, it controls which of these inputs is used. Let's actually go to the other material. Copy all these nodes. Press Ctrl C to copy them, and here press Ctrl V to paste them. Now we should connect the mesh paint texture replace to the alpha input here. But we need to add one more node before connecting it. Just like vertex painting, we need to have control over which channel we want to paint on. So after mesh paint texture replace, we should add a node to do that. Right click and search for breakout. We need this one, breakout float 4. So let's add it and connect them like this. This is a material function. If we double click on it, we can open it. So let's open it. We can see that it's just 4 component mask nodes and each of them is masking one of the channels. So let's close it. And also this one. So now that we've connected these two, we can control which channel to use as the alpha. For this one, I'll use the R channel. So let's connect it like this. And one more thing, make sure you've connected the RGBA output of the texture. So let's do that. We want to be able to use all the channels. Now for the default input, let's hold 1 and click to add a constant and connect it. The value of 0 is fine. When it's set to 0, we can see the A input of the lerp by default. Connect the lerp to the base color input, save the material, and let's check it in the level. I've already added a cube and a plane in the level. If we set the view mode to wireframe, we can see that they're just 2 simple meshes. The plane has only UV channel 0, but the cube has both UV channel 0 and 1. I want to show you how to paint on the other UV channels too. Also find your meshes in the content browser and make sure nanite is enabled. assign the material to both of them. And now finally, let's actually use the texture color tab in the mesh paint mode. But before that, like this video and subscribe. Join my Patreon for early access to videos and exclusive assets, and join our Telegram and Discord communities to stay connected. All the links are in the description. Texture color mesh paint. Let's start with the plane. On the top left, click here and go to the mesh paint mode. We have 4 different tabs. As you can see, vertex color can't be used here. The paint option is grayed out. But if we disable nanite on the mesh and save it, we can see that now the paint option is enabled. I just had to go to the texture color tab and go back to the vertex color tab. So per instance, vertex painting isn't supported on nanite meshes, as we said earlier in the video. Let's enable nanite for the purpose of this video and save the mesh and continue. Now again, if I go to the texture color tab and go back to the vertex color tab, we can see that the paint option is disabled. The texture color tab is the one we're gonna use. It's been added in the 5.5 version. The add button here creates a blank virtual texture asset which gets assigned to the mesh paint texture. If it's grayed out, check that virtual textures have been enabled for your project. So let's click on it, and some of the other buttons are now enabled. We can inspect the virtual texture in the meshes details panel under the mesh painting category. Here it is. By default, it's blank or black, and that's why I set the default value in the material to 0, so the appearance of the object doesn't change when we add the texture color. So let's select paint, and the paint options appear here. Color view mode shows us the different channels when painting. These are the paint color, the erase color, and the channels we want to paint on. If propagate to vertex color is enabled, it automatically copies all the texture color painting to vertex colors. These parameters control the brush. They are pretty much self-explanatory. And these parameters are for when we want to use our own brushes. Enable seam painting is very useful. By default, when painting on the mesh, the seams are obvious. We can see it on this Megascans asset. Enabling this option fixes this issue. So let's enable it, and now we can paint on the seams too. But it's buggy. Sometimes it works, but sometimes it doesn't. So this is definitely one of the things they should fix in the future versions. When the mesh is selected, in the Details tab under the Mesh Painting section, we can enable or disable vertex color mesh painting and texture color mesh painting for this specific instance. Now let's start painting. Make sure the object is selected, and here only enable the red channel. That's the channel we used in the material. And now we can start painting. Let's set the strength to 1. Use the brush parameters to better control how you paint. If you feel like the resolution is low, we can fix it from the Details tab. Here under Advanced, we have these 2 options to override. This one is Texture Coordinate Index, and this one is Mesh Paint Texture Resolution. By default, these 2 are specified in the project settings for the whole project, or in the static mesh editor for each static mesh, but we can override them individually on each instance in the level from here in the Details tab. So enable overridden mesh paint texture resolution, and let's set it to a higher value like 256. The resolution should be a power of 2. If it's not, it will automatically change to the nearest power of 2 in the background when creating the texture. Now under texture color, we can either click on fix to set the new resolution, or click on remove to remove this low resolution texture, and then click on add to add a new one with the new resolution. I'm gonna go with fix. So let's click on it, and now it's much smoother because it has a higher quality. So just changing the resolution in the Details tab doesn't affect the existing mesh paint textures. We should either fix it or remove it and add a new one with the new resolution. The swap button switches the paint and the erase colors. So right now the paint color is white and the erase color is black, and if we click on swap, now the paint color is black and the erase color is white. So now we can paint on the mesh to remove the red parts. Or if the paint color is white and the erase color is black, let's swap them again. So if the paint color is white and the erase color is black, now we can click and drag to paint the red color, or hold shift while doing that to use the erase color. Also check out the mesh paint texture as we paint on it. You can see it updates. Let's remove everything. And let's set the size to 0.2 and write something like Hoj D. Fill fills the mesh with the paint color. Make sure that the brush strength is set to 1 when using it. Otherwise, it doesn't work correctly. So let's fill it with black. And now if I set the strength to 0.5 and fill it again, we can see that it is a very light red, kinda pink. That's because the strength should be set to 1. Adding more layers to the material. Right now we can only paint on the red channel. Let's add more colors so we can use the other channels too. Select the red channel and press Ctrl D to duplicate it here. Let's actually duplicate it 2 more times. I'll set this one to green, this one to blue, and this one to black. First I'm gonna lerp between the result of this one and the green color. So let's hold L and click to add a lerp node. Connect this lerp to the A input and the green color to the B input. For the alpha, I'm gonna use the G channel of the mesh paint texture. So let's drag it and connect it like this. Connect the lerp to the base color and save the material. And now if I enable the green channel, we can paint the green color. The red channel paints the red color. And if I enable both of them, I'll get a combination of these 2 colors. But let's not do that. We should do the same for these 2 colors. So add 2 lerps, connect them like this, and connect the blue color to the B input of this one and the black color to the B input of this one. For the blue color, I'm gonna use the B channel of the mesh paint texture. And for the black color, I'm gonna use the alpha channel. Connect them, save the material. Now, we can use the blue channel to paint blue and the alpha channel to paint black. Painting on the other UV channels. Right now we can only paint on UV channel 0. Let's go over how to paint on the other UV channels too. By default, the texture sample node uses UV channel 0, so that's what the mesh paint texture uses. On the plane, it doesn't really matter. The difference is not visible, but let's paint on the cube. So select it, go to the mesh paint mode, texture color, add it, and click on paint. Let's enable the red channel only and start painting. As you can see, we're painting here, but it paints on all the sides. And that's because of the way its UV islands are placed in UV channel 0. Let's open the cube static mesh and open UV channel 0. As you can see, all the islands are on top of each other. That's why when we use UV channel 0 and paint on one of the sides, the paint is added on all of the sides. But in UV channel 1, all the islands are placed individually and none of them overlap. All 6 faces of the cube get their own spot within the UV space, so it will work just fine. When looking at whether a UV is suitable for texture color painting, you'll want to see if it has any overlapping, tiling, or repeating UVs. If it does, you'll want to have a UV channel that lays out the UV charts so that each part of the geometry has a unique ID. How can we use it though? In the Details tab of the Static Mesh Editor, search for Mesh Paint. These are the mesh paint parameters for this specific static mesh. We can set them in the project settings for all the meshes, or we can set them per static mesh in the static mesh editor. So for example, for this specific mesh, I want mesh paint's texture coordinate index to be 1. Save and close it. In the level, we have the mesh paint section in the Details tab. We can also change the settings for each instance from here. So let's remove this one, add another one, and paint on it. It doesn't work correctly though. That's because we should edit the material too. So let's get back in the material. This number in front of the UV's input can be used to change the coordinate index. You should set it so it matches the mesh paint texture coordinate index on the static mesh or the overridden mesh paint texture coordinate index on a static mesh component. So let's set it to 1. Save the material. And now if I remove and add it, we can paint on it correctly. But what if we want to use the same material for different meshes with different UV indexes? For example, here the plane uses UV index 0, the cube uses UV index 1, and the cylinder uses UV index 2. There are no direct parameters to control the UV index of the texture sample from a material instance, but there's a workaround for it. We can add multiple texture coordinates, so press U on the keyboard and click to add one, and press Ctrl D to duplicate it 2 times in my case. Let's set this one to 1 and this one to 2. Now we can use the switch node to select which one we want to use. So let's add it. Here it is. Add 3 inputs. This one is index 0, index 1, and index 2. Connect them like this based on their index, and I'll connect coordinate index 0 to the default input. Let's connect the switch node to the UV's input, and here's where the mesh paint texture coordinate index comes in handy. So let's move it here. We can connect it to the switch value and it will control which of these texture coordinate nodes is used. It actually outputs the coordinate index value we have entered for each static mesh, or the overridden value we have used in the details tab for each instance. So save the material. Let's first assign the material to the cylinder 2. Go to the mesh paint mode. And now we can use the same material for all of these meshes, and we can paint on all of them and it works correctly. Let's remove these two and add a new texture for all of them. Go to the paint mode, and as you can remember, when you want to change the meshes, you have to first select the select button, select it, and then select the paint button. So now, as you can see, we can paint on all of them and it works correctly. Using mesh paint to add tint to surfaces. Right-click in the content browser and create a material. Let's name it m_tint mesh paint tint. Save it and open it. Here search for nanite and enable used with nanite. And first I'm gonna add the mesh paint nodes. So let's right click, search for mesh paint. I want the mesh paint texture object and mesh paint texture replace. Hold T and click to add a texture sample and connect them like this. For the default input, I'm gonna use a color. So hold 3 and click to add a vector 3 and connect it to the default input. I will set the default color to 1, which is white. Connect the mesh paint texture replace to the base color. Save the material. And let's check it in the level. Assign the material to this plane and go to the mesh paint mode. Texture color tab, select it, add one, and select the paint option. In the material, I used the RGB output. So here let's enable the red, the green, and the blue channels. And now we can set the paint color to any color we want and start painting. We can use this material logic to add tint. Let me show you how. So, go to Content, Starter Content, Textures, and let's add these two brick textures to the material. This is the base color, and this one is the normal. Now, we can add tint by multiplying this texture by the mesh paint texture replace. So let's do that. Let's hold M and click to add a multiply node. Connect the texture to the A input and the mesh paint texture replace to the B input. And let's connect it to the base color. Let's save the material. When we add texture color, the virtual texture is black by default. Black means 0, and 0 multiplied by any color is 0. That's why the plane is black right now. So let's set the paint color to white. And click on fill. White is 1, so any texture or color multiplied by it results in the same texture or color. That's why now we get the brick texture. To add tint, we can set the paint color to any color we want. For example, this darker tint. Click on OK and start painting. We can tweak the brush settings to better control what we're doing. For example, let's set it to a kind of brown color. And let's set the strength to something lower like 0.6 and start painting here. Here's the example in the documentation using the same method. Next, I'm gonna go over the rest of these buttons. The other buttons. We can click on the Save button to save the modified virtual texture for the object which is selected in the level. Color data stored on one of the instances can be copied to the other instances of the mesh. We can use the copy and the paste buttons to do that. For example, I've copied this object 2 times over here and they don't have texture color data. So now we can select this plane, go under the texture color tab and click on copy, then select these 2 planes and click on paste and the texture color will be copied on them. The vertex button imports color information from the vertices onto the texture color. I actually couldn't get it to work correctly. Here's the plane and here are its vertices. I've actually assigned a vertex color material to it. Now under the texture color tab, if I first assign the texture color material to it and then click on vertex, we can see that nothing happens. So if anyone figures out how it works, please tell me in the comments below. The fix button can be used when we change the resolution of the mesh paint texture. Instead of removing and adding a new texture color, we can simply use this button. For example, right now if I paint on this cube, we can let's set the paint color to white. Let's increase the size and the strength. We can see that the resolution is too low. So let's increase the resolution from here. Enable the option and let's set it to 256. Now if I click on fix, we can see the effect. Considerations. Let's go over some things to consider when using this feature. This feature can be used with both nanite and non-nanite meshes. There are times when you want to prevent the unwanted creation of mesh paint textures, so it's useful to filter out some meshes or specific instances of meshes in a scene. So let's open this static mesh. We can disable mesh texture painting per static mesh from the static mesh editor by changing the support texture color mesh painting setting. So these are the options. Default means that it will use the option that is selected in the project settings. Enabled means it is enabled, and we can disable it by selecting the disabled option. Alternatively, we can disable painting on a static mesh component per instance. So for that, we should go to the details tab and scroll down. Under mesh painting, we can disable the second option. When texture color painting on a mesh asset or mesh instance is disabled, this will not remove existing texture data. It only prevents the creation or modification of the mesh paint texture. For example, it is disabled on this cube. As you can see, the texture color data stays on the mesh and we can see it here too. But if I go to the mesh paint mode and texture color, we can see that we can't paint on it. We only have the option to remove the existing texture color. But if I enable it from here, we can see that now we can paint on it. How the mesh is unwrapped can affect the resolution. We can see that on the cube. Right now we're using UV channel 0 and a resolution of 256. Let's paint on it. We can see that it has a good quality. but let's set it to UV channel 1 and now paint on it, and as you can see the resolution is lower and we can see the pixels. That's because of how the UV islands are sized and placed. We can paint on multiple meshes at the same time. For example, let's add this plane here, move it up, and let's duplicate it 9 times. Now let's select all of them and assign the mesh paint material to it. Go to the mesh paint mode. Under texture color, click on add and let's paint on it. Now let's disable sim painting, paint. Let's actually increase the resolution to something higher. And fix it. And now let's paint. As you can see, the sims will look bad, but it will probably be fixed in the next versions. We could also copy the mesh paint texture from a mesh onto another mesh. For example, from this plane onto this cube, but it won't look good, so we don't usually do that. When setting the mesh paint texture resolution, keep an eye on the mesh paint texture resource as well. Here it is. Here's the size when the resolution is set to 256, and now if I increase it to 1024 and fix it, we can see that it has severely increased. It can easily get out of hand, especially if you're using this feature on a lot of instances. In the project settings, we have several parameters to control virtual textures and mesh paint. I always use the default settings, but feel free to tweak them if you like to. Make sure to find a good resolution for each mesh, then start painting on it, so you won't need to tweak the resolution mid-texture painting. For example, on this plane, if I decrease the resolution and click on fix, then increase it and fix it again, we can see that the quality changes. So keep this in mind. Just increasing or decreasing the resolution is fine, but decreasing it and then increasing it again, it doesn't work well. It doesn't matter if you're using a triplanar material, the mesh painting should happen in the texture coordinate space, not the world space. So you can create a triplanar material with world projection, but the mesh paint texture should use a texture coordinate. We could use world position for it, but it just doesn't make sense and makes things a lot complicated for no reason. This feature also works with Path Tracer. Painting color to a mesh paint texture instead of a mesh's vertices has the advantage that the texture size can be chosen independently of the vertex density. This can be good if your meshes don't need such a high resolution for painting, but may be limiting on some platforms with smaller frame budgets. For texture colors, the mesh paint texture resource size isn't the final size in a staged package because it doesn't take into account packaging compression that happens for all textures in the project. Also, this is not the size in memory because this mode uses virtual texturing, which has a fixed memory cost overhead defined by shared virtual texture pools. We can set the resolution or size of the mesh paint texture either from the static mesh editor or on each instance in the level. By default, it is set to 0, which means the system automatically decides the default size of the texture based on certain built-in rules. It is based on the number of vertices in the LOD0 of the non-nanite mesh. Here's how it is calculated. Minimum number of text cells equals to mesh paint text cells per vertex multiplied by number of vertices in LOD0 of the mesh. Mesh paint text cells per vertex can be set from the project settings. So let's go to the project settings and search for mesh paint text cell. Here it is, mesh paint text cells per vertex. The texture size will be the first power of 2 that has more text cells than this. The mesh paint texture resolution is always rounded to the nearest power of 2. In times where the UVs are not set up suitably for mesh painting, the mesh tool will still function, but you can get unexpected results, like painting on one part of the mesh and having it also paint on other parts of the mesh. We can generate a new UV set from within the static mesh editor. In the Details tab, find the Generate Lightmap UVs option and enable it. Set the resolution, the source lightmap index and the destination index and click on Apply Changes. It will generate lightmap UVs and will move them to the index you've specified here. In the project settings, search for Virtual Texture. And down here we have the mesh paint settings. We can hold the mouse on top of them to see what each of them does. Also, if you want to learn more, I'll put the links to the documentation in the description below. In this material, I only used colors to demonstrate how this feature works. But we can also use it to layer between textures. It can also be used as the alpha of a blend material attributes node. In fact, we can use it to create the same material we created in this tutorial with vertex colors. You can join my Patreon to have early access to videos like this. And that's it. Click here for more Unreal stuff, and thank you so much for watching. Massive shout out to my patrons for making this possible. Like this video, subscribe and join our communities. If you have any questions, leave them in the comment section below. So, see you in the next one.